This is one of my favorite examples in Mathematica. It's simple, it's short, it's a lot of fun to play with, and it makes good use of various different kinds of functionality within Mathematica. Let's first look at what it does and then sort of go back and see how it does it. Evaluate this, you get a little output with a bunch of points in it, which you can drag around. And when you drag them around, these little patches of color follow. So what's going on here? The answer is that for each patch of color represents the area which is closer to the locator inside it than to any other one of these locators. So if you make a little sort of a narrow area and move one through between it, you'll see it kind of squeezes through, and it's always showing you what is the land that is closest to that particular point. And this is actually a rather complicated thing to calculate, you might think. And it's somewhat surprising that you can do it with such a small amount of code. In fact, where is the calculation in here? Well, the answer is that list density plot will do it for you automatically. List density plot is normally intended to be used for plotting interpolated surfaces where you've specified points, not necessarily on a regular grid, but you've specified X, Y, Z data points, and it's interpolating a smooth Z surface through them, and then plotting that as a density plot with a certain color gradient. In this case, we've given it the option interpolation order 0, which means that rather than linearly interpolating or quadratically interpolating between the different Z values, we want it to just give constant values of Z over different patches of area. And then we've given it a set of data points which consists of X, Y points that are determined by the location of these locators, which have been initialized to a set of 10 random X, Y points. And then the Z values are just steps, 1, 2, 3, 4, however many data points you have. So each point is assigned a different Z value, and by saying interpolation order 0, list density plot is instructed to interpolate around that data point at 0 order. So in other words, don't change the value of Z. And it chooses to do that quite sensibly by dividing up the area into the points, portions of the plane that are nearest to each point, and assigning that point's Z value to that area. So that's how you get this calculation of nearest surface, just because that's how list density plot chooses to do this particular plotting task. Now, there's a couple other nice things you get. For example, you can use command click or alt clicking on a Windows machine to add new data points. So we can click around here and make a whole bunch of them and get progressively smaller patches of color. That is possible because of the option Locator Auto Create, which has been added to the manipulate locator specification. The value 3, infinity means a minimum of 3 and no maximum limit to the number of locators. So if you command click on or alt on an existing one, it deletes it, but it won't let us go below 3. Another thing you can do with this example is choose from a wide range of color gradients. Some of them sensible, some of them maybe not so sensible. And again, you might ask, well, where does this long list come from in this input command? It's too short. And the answer is a data packlet called color data, which provides for you a wide range of different kinds of useful color information. One of the things it supplies is a list of gradients. So color data of gradients will return a list of gradients, a list of names of gradients like this. This has been given to manipulate as a set of values that the variable colors is supposed to be able to take on. Manipulate chooses to present that choice as a pop-up menu. And then list density plot is instructed to use this gradient as its color function. So, this is an example of how things just sort of fit together in Mathematica. The fact that there's no sort of extra processing of this data. What's made available in color data is exactly what you need in order to use in list density plot or in manipulate or in 100 other functions where you might want to use color information. So these things, these sort of different elements, quite disparate set of functions, a sophisticated visualization function, a very high-level user interface specification function, and a data service function work together to produce, in a very small amount of code, a nice little interactive thing with sort of surprisingly pleasing options, like being able to choose these different colors that you normally just wouldn't have available without an awful lot of extra work.